Dear student, today we are going to learn about non-inverting amplifier. In this lecture, we will discuss about the open loop and closed loop non-inverting amplifier. We will also derive the voltage gain equation of non-inverting amplifier, and we will take one example to design the non-inverting amplifier using NI Multisim software. So, as we have already discussed in our previous lecture, that the problem with op-amp is that the output gain of an op-amp is very high in an open loop configuration, and that makes the op-amp unstable and difficult to control. Therefore, to overcome this problem, closed loop op-amp configuration has been generally considered. So here, in case of open loop non-inverting amplifier, this is the diagram of open loop non-inverting amplifier, because as you know, in case of open loop, the feedback path is not present. So here, the feedback path is not present, that is in between output or input. So the feedback path is not present here. So this circuitry will be act as an open loop non-inverting amplifier. So in case of this non-inverting amplifier, this because this is non-inverting, so here we will apply the input voltage at non-inverting mode, and inverting mode is directly grounded, and this is the resistor R1 connected at non-inverting mode, and these are the supply voltages, that is plus VCC and minus VE, and this is the output. So, according to that figure, the open loop non-inverting amplifier, the input signal is applied to the non-inverting terminal of an op-amp, and the inverting terminal is directly connected to the ground. The output voltage of open loop non-inverting amplifier is V naught is equal to A into VID, and here this is the input differential voltage. So here this is equal to A into VID, and this VID is equal to difference of two input voltages. So this is V1 minus V2, and this is equal to A into V1 minus. So here V2 is equal to 0. Why? Because V2 is in case of non-inverting amplifier is directly grounded like this. So here this V2 is directly grounded, so this V2 equal to 0. So here this is equal to 0, and now this will be equal to A into V1. So this is also equal to A into Vin. So in case of open loop non-inverting amplifier, the output voltage will be equal to A into Vin. So this is the diagram, and if in case of closed loop non-inverting amplifier, here closed loop means the feedback path is present. So in case of closed loop non-inverting amplifier, the output is in phase with respect to the input. So here at non-inverting mode, the input is applied here, and at inverting mode, here the R1 and RF are connected here, and this is the output. So in case of closed loop non-inverting amplifier, this is an example of voltage series feedback of closed loop op-amp configuration. Similar to inverting amplifier, considering the op-amp to be ideal so that it will have infinite gain. Therefore, here the input differential voltage, that is equal to V naught upon A, and here the A should be equal to infinite. So VID is equal to 0. So here the VID is equal to V1 minus V2, and that is equal to 0. And we can also write this equation, this V1 minus V2 is equal to 0, and therefore V1 is equal to V2, provided the gain is very large here. So here in this here this V1 is also equal to Vn, and V2 is also equal to Vn. Why it is? Because this V1 is equal to V2, but here in this diagram, this V2 is also equal to V in. So here this V1 is equal to V in and V2 is also equal to V in. Therefore, V2 is not equal to 0. So that means non-inverting amplifier has neither of the input terminal at virtual ground. Therefore, V2 is equal to Vf. Therefore, applying voltage divider theorem in feedback network for Vf. So, in case of non-inverting amplifier, here we are applying the voltage divider theorem. So, here this Vf according to this circuitry, here this is Vf. So, how to calculate this Vf? That is equal to here this Vf equal to R1 into V naught upon R1 plus Rf. So, in case of Vf, this is R1 and this is the resistance, and across this resistance the voltage is equal to V naught. So, we can write Vf is equal to R1 across voltage is V naught upon Rf. So, R1 plus Rf. So, here this is the total resistance. So, according to voltage divider theorem, the Vf should be equal to R1 into V naught upon total resistance, that is R1 plus Rf. So, in case of closed loop non-inverting amplifier, the gain should be equal to like this. This V naught upon V in equal to R1 plus Rf upon R1, and that is equal to 1 plus Rf upon R1. So here the AF is equal to V naught upon V in, output voltage upon input voltage, and that is equal to 1 plus Rf upon R1. So as you can see here, in case of closed loop in non-inverting amplifier, the voltage gain is equal to 1 plus Rf upon R1. So here the gain is equal to 1 plus Rf upon R1, and now we are taking this example, and for the non-inverting amplifier, this RF here the RF is given, that is equal to 10 kilo ohm and R1 is equal to 1 kilo ohm. Therefore, determine the closed loop voltage gain, that is indicated by AV, or you can indicate also by AF. So here the closed loop voltage gain is AF is equal to, or we can say AV equal to 1 plus Rf upon R1, and that is equal to 1 plus 10 upon 1. So here Rf is given 10 kilo ohm and R1 is given 1 kilo ohm. So according to this, this is equal to 11. So here the voltage gain is 11 and the positive sign indicates the non-inverting mode or output is in phase with respect to the input. So this is the example, and using this example, we will also design the design the circuitry of non-inverting amplifier using Multisim software. So here we can design the circuitry. So now we are using the Multisim software here. This is the Multisim software, and here now let's construct the circuit. So here these are the op-amp ICs, and here you can select the 741 IC and drag it, and here these are the components, resistor, capacitor, etc. So you can select it, select the resistor and drag it, and one more resistor, select it and drag it. Now select the ground terminal also, select it and drag it. Now select the supply voltages. So here these are the ground terminals. Now select the plus VCC. This is the supply voltage, and minus VE also. Now you can also select the function generator for the input signal. So here select the function generator. You can also select the oscilloscope from instrument toolbar and connect the wiring also. So these components we want to design the circuitry. You can assemble all the component into the workspace and then connect the wiring like this. So here this is the R1 resistor. Flip it vertically or rotate it also. So rotate this resistance and then connect to the ground terminal and now connect it to the inverting mode. So here you can set this resistor R1 like this and this is the output and that is connected to the CRO channel B terminal and this is negative terminal is grounded and here this is also grounded and the R2 one terminal of R2 is connected to the inverting mode and other one is connected to the output and this is the supply voltage minus VE that is connected to the pin number 4 of 741 IC and plus VCC connect to the pin number 7 and here this is the ground terminal and you can connect the non-inverting terminal of the 741 IC to the function generator input and this is also connected to the input of the function generator. You can also delete the components also if not needed and you can also change the value. So here we are considering the supply voltages that is plus 15 or minus 15 volt. So we can change these values. So now the circuit is ready. To simulate our circuit by clicking F5, click on the function generator. Here first we can because in our example the R2 here R2 is also considering as RF because this is the feedback resistor, so you can change the level also. So here this is 10 kilo ohm according to our example. Now run the simulation button by clicking like this and change the by clicking the on the function generator you can change the frequency also or you can change the amplitude also and like this you can change the scale and here this is the function generator and we can change the amplitude. So here we can change the amplitude. Here we are considering 3 millivolt and we can also change the frequency. So here we are considering the 1 kilohertz frequency. So as you can see here, we can change also, and like this. These are the output result. So as you can see here, the input is like this, and this is the output. So here, this is the input and this is your output. So these is in phase and the results are correct. So we can say in case of non-inverting amplifier, the output is in phase. So if we are applying the input voltage, then the output is in same phase. So these are the output result and these are correct. So you can design any type of circuitry like this. Thank you for watching.